Hi friends,
Hello.
very good morning.
Morning.
Today we will learn about imperfections. Now, what is mean by imperfections? So any kind of a thing in a universe is not having a perfect body. Always there is some defect. A coin. So coin has an advantage and disadvantage. Coin has a two sides, heads and tails. As it is, every solid substance has a two sides. One is an advantage and another is disadvantage. So disadvantage we can refer as an imperfection in solids. Okay, so basically the imperfections are of two types. So the place where there should be an atom, but now it is not present. So this kind of defect is called as a vacancy defect. While the another type of defect in which there is no atom originally in that place, but somehow the atom from a different place got stuck to that place and it increases the density of the atom. So this kind of defect is called as an interstitial defect. We can say it up. Okay. So now we will learn about all the kind of imperfections, and mostly there are two main topics which is called as Scotch effect and Frankel effect, and it is one of the important effects. Okay, so imperfections in solid. So although crystalline solids have short range as well as a long range order in an arrangement of a constituent particles, yet crystal are not perfect. Means when we are seeing in a long chain, it is never perfect. Always there is some defect, some damage in a solid. Okay, so usually solid consists of an aggregate of a large and small crystals. This small crystals have defect. This happens when a crystallization process occurs at a fast or moderate. Means when we are creating a polyethylene. So polyethylene, if I am creating very fast, there will be some defect. If I am keeping the process very slow, there will also be a defect. So we have to always work with an optimum condition. It is always required. Okay, so even these crystals are not free of defects. Means if we are creating very optimum condition, there will be some very small or negligible, but it will always have a defect. Okay, now the defect are basically irregularities in the arrangement of a constituent particle. You should underline this, that what is mean by a defect? Defect is an irregularity in arrangement of the constituent particle. Broadly speaking, the defect are of two types, namely point defect and line defect. Now, these words are very similar and it is a type of a defect. Now, if I am talking about the room and only one corner of a room is defected, then it is called as a point defect. But if an entire row in a room is defected, then this is called as a line defect. Simple means if एक ही जगह पर खाली डिफेक्शन है तो हम लोग उसको point defect बोलेंगे, and पूरा row की पूरा line of the bunch is defected, then we can call it as a line defect. Okay, now point defects are the irregularities or the deviations from the ideal arrangement around a point or the atom in the crystalline substance. Means a point और एटम के आजू बाजू खाली डिफेक्ट है तो उसको हम लोग क्या बोलेंगे? Okay, it is a point defect, whereas a line defect are the irregularity or the deviation from ideal arrangement in an entire row of a lattice point. Means if the defect is there in an entire row, then we can tell that it is a line defect. Okay, so these irregularities are called crystal defect. We shall continue our discussion with the point defect only. Means in this chapter, we are only going to learn about a point defect. We are not concerned about a line defect, obviously. Okay? So now, types of point defect. Now, there are mainly many kind of point defects, but we will learn only some of the point defects. So point defects are classified into three types. First, stoichiometric defect. Second one is impurity defect, and third one is non-stoichiometric defect. Now, every time stoichiometric means a 1 centimeter cube has one defect, then 2 centimeter cube has two defects. Mean if it is proportional to the volume, then we can say it is a stoichiometric defect. Means 1 centimeter में एक डिफेक्ट मेरे को मिल रहा है, then 2 centimeter में मुझे एक ही डिफेक्ट मिलेगा. So it is known as a stoichiometric defect. Okay, so those are the point defect that do not disturb the stoichiometry of the solid. Means वो लोग एक जगह पर बहुत सारा डिफेक्ट है, दूसरी जगह पर नहीं है, ऐसा नहीं है, सब जगह कॉमन डिफेक्ट है, तो वो केमिकल प्रॉपर्टीज चेंज नहीं करता है, तो इट इज नोन एज स्टोइकोमेट्रिक डिफेक्ट. ओके, सो दे आर also an intrinsic or thermodynamic defect. Basically, these are two type of defect: vacancy defect and interstitial defect. Always remember, stoichiometric defect is very wide range defect. If I am getting an ore from Delhi, or iron ore from Delhi and iron ore from Mumbai, तो iron ore same है, constituent same है, but उसका defect का proportion या amount of defect will be never same because we have extracted two ores from a different place. Okay, so this is a vacancy. We are studying vacancy defect and interstitial defect. Okay, so now vacancy defect. So when some of the lattice sites are vacant, the crystal is said to be having a vacancy defect. Okay, means जो जगह पे एटम होना चाहिए वहां पर एटम नहीं है, उसका मतलब क्या कि it is having a vacancy, तो उसको हम क्या बोलेंगे, it is known as a vacancy defect. Okay, so this result into the decrease in density. अब क्लास में 30 स्टूडेंट्स होने चाहिए, ठीक है, अब उसमें से 2 स्टूडेंट्स वहां पर नहीं बैठे, कहीं घूमने चले गए, उसका मतलब क्या कि there is decrease in the number of atoms, there is decrease in the number of students, उसका मतलब डेंसिटी आपका ऑब्वियस है डिक्रीज होने ही वाला है, ठीक है. So this defect can also develop when a substance is heated. मतलब जब भी हम कोई solid substance को heat करते हैं, the substance is heated, that this kind of vacancy defect is produced. Okay, now the another type of example or the defect, it is called as an interstitial defect. So when some constituent particles occupy interstitial side, मतलब क्या कि क्लास में 30 स्टूडेंट्स है, बट मेरा फ्रेंड है या आपका कोई फ्रेंड होगा, वो कहीं से आके आपके बाजू में बैठ गया, होता है ना कि एक दो टू स्टूडेंट, इफ द बेंच इज ऑफ 2 स्टूडेंट कैपेसिटी एंड इफ थर्ड स्टूडेंट tries to sit there, he will be able to sit, but density बढ़ गया, आपको जितना जगह पहले मिलता था उतना जगह अब नहीं मिलेगा. So when some constituent particles occupy an interstitial site, the crystal is said to be interstitial defect. This defect increase the density of substance. मतलब पहले 2 थे तो अब 3 हो गए, मतलब डेंसिटी तो ऑब्वियस है ना, इंक्रीज होगा ही होगा. Okay, got it or not? Okay, now vacancy and interstitial defect as explained above can be shown by non-ionic and ionic. हम लोग vacancy interstitial defect हम लोग दोनों टाइप का देख सकते हैं, ionic भी हो सकता है, non-ionic भी हो सकता है. Okay, so ionic solid must always maintain electrical neutrality. मतलब अब non-ionic है तो उसमें तो ions का कोई मैटर नहीं करता है, but if there is a ionic solids means ionic होता है, मतलब एक cation गया तो दूसरा एनायन जाना ही चाहिए, तभी तो हम लोग इलेक्ट्रिकल न्यूट्रल होंगे, अदरवाइज तो ये इट विल बी बिकम पॉजिटिवली चार्ज और नेगेटिवली चार्ज. सो we don't do this. Okay, so rather than the simple vacancy or the interstitial defect, they show a Frankel defect and Schottky defect. मतलब जो vacancy defect है वो जो ionic solids है उसमें हम लोग कुछ अलग बोलेंगे, और interstitial defect है उसको हम लोग कुछ अलग बोलेंगे, ठीक है. So this figure number 1.23 is a diagram for vacancy defect. Okay, so उसमें हमको vacancy defect दिया है कि देखो वहां पर एटम होने चाहिए थे व्हाइट बॉक्सेस में, पर वहां पर एटम नहीं है, तो उसको हम लोग क्या बोलेंगे, तो क्या उसको हम लोग vacancy defect बोलेंगे. इट्स सिंपल. Okay, so now the interstitial defect in a ionic compound, उसको हम लोग Frankel defect बोल सकते हैं, ठीक है. उसका मतलब क्या कि the defect, हाँ, और ये 1.24 फिगर है, इट इज अ इंटरस्टिशियल डिफेक्ट बिकॉज ये जो 5 एटम्स का ग्रुप है वहां पर एटम होना नहीं चाहिए था ओरिजिनली में, बट क्या हुआ कि कहीं से एटम आके वहां पर स्टक हो गया. सो डेंस एटम नंबर ऑफ एटम इंक्रीजेस देन ओरिजिनल एटम, सो द डेंसिटी विल आल्सो इंक्रीज. सो दिस काइंड ऑफ defect, it is known as an interstitial defect. Okay, so if you have any doubts, then let me know in a comment box. Okay, so now we are getting a Frankel defect. So what is mean by Frankel defect? So the defect is shown by ionic solids. The smaller ions, मतलब हमेशा ये जो डिफेक्ट होता है ना फ्रेंकल डिफेक्ट, उसमें हमको तो साइज मैटर्स अ लॉट। मतलब कैट आयन बहुत स्मॉल होना चाहिए एंड एन आयन बहुत बड़ा होना चाहिए, या वाइसा वर्सा, इट डजंट मैटर्स टू अस, बट देयर शुड अ लार्ज change in a size or the diameter of the atom. Okay, so smaller ion, usually cation, is dislocated from its original normal site and to an interstitial site. It creates a vacancy defect and its original site and interstitial defect as a new location. मतलब वो जहां पर होना चाहिए वो कहीं जा नहीं रहा है। क्या हो रहा है, एटम में पहले भी 10 थे, अभी भी 10 एटम है, पर जहां पर होना चाहिए वहां पर नहीं है, और कोई दूसरे क्लास पे मतलब दूसरी जगह पर बैठ गया। फॉर एन एग्जाम्पल, हमारा एक क्लास है, उसमें 30 स्टूडेंट्स है। अब 30 स्टूडेंट, ना कोई स्टूडेंट बाहर जा रहा है ना कोई स्टूडेंट अंदर आ रहा है, बट क्या हो रहा है, जो लास्ट बेंच पे मेरा फ्रेंड बैठा है वो फर्स्ट बेंच में हम दो फ्रेंड बैठे हैं ना उसके साथ आके बैठना चाहता है, तो इट इज नोन एज फ्रेंकल इफेक्ट। बिकॉज ना डेंसिटी बढ़ी है ना डेंसिटी कम हुआ है, बट खाली हुआ क्या, तो कि वो अपना जगह छोड़ के वही सेम क्लास में वो मेरे जहां जगह पर नहीं थी वहां पर वो आ गया। ठीक है, so Frankel defect is also known as a dislocation, मतलब कि Frankel defect is nothing, it neither decreases in density, neither increases in density, but it is only called as a dislocation defect. Okay, so it does not change the density of solid. Frankel defect is shown by the ionic substance in which there is a large difference in the size of ions. Okay, means हमने पहले ही बात किया कि there should be a huge quantity of a size difference in a two cations and anions respectively. Okay, so for example ZnS, now sulfur is having a small size as compared to zinc, as same silver AgCl, silver chloride, then silver bromide and AgI. Now here AgBr is most important compound. It is showing Frankel defect as well as it will be showing us a Scotch effect. Okay, so remember this thing. Okay, any doubts you can ask me. So now we are concerned about a Scotch effect. So it is basically a vacancy defect in an ionic solid in order to maintain the electrical neutrality. मतलब it is a vacancy defect, मतलब जो 30 स्टूडेंट्स है ना उसके जगह पर का तो 31 हो जाएंगे का तो 29 हो जाएंगे, मतलब इसमें कुछ तो होगा, इसमें वैकेंसी डिफेक्ट होने वाला है। ठीक है, सो इट इज बेसिकली अ वैकेंसी डिफेक्ट इन आयोनिक सॉलिड in order to maintain the electrical neutrality, the number of missing cations or anions equal. मतलब if एक cation बाहर से आता है तो उसके साथ साथ anion भी आना चाहिए। if cation क्लास के बाहर जाता है तो anion भी क्लास के बाहर जाना चाहिए। ठीक है, मतलब इलेक्ट्रिकल न्यूट्रलिटी तो मेंटेन करना ही पड़ेगा। ठीक है, so like simple vacancy defect, Schottky defect also decrease the density. मतलब vacancy defect कोई भी हो, आयोनिक में हो नॉन आयोनिक में हो, डेंसिटी तो कम होगा ही होगा। ठीक है, so number of such defects in an ionic solid is quite significant. For example, in NaCl there are approximately 10 raised to 6 pairs of Schottky defect per centimeter cube. मतलब 1 सेंटीमीटर क्यूब में 10 raised to 6 Schottky defect होता है at a room temperature in 1 centimeter cube. अब हमें पता है कि 1 centimeter cube होगा तो approximately there are 10 raised to 22 ion, because 1 mole होता है ना, तो 1 mole में 6.02 into 10 raised to 23 atoms होते हैं। उसका मतलब कि 1 centimeter cube में approximately, हर बार कांस्टेंट नहीं होता बट अप्रोक्सीमेटली आगे कोई भी नंबर हो सकता है, बट इट विल बी इन अ पावर ऑफ 10 raised to 22. सो वी कैन से दैट एक Schottky defect 10 raised to 6 atom में, तो 10 raised to 22 atom में कितना, so it will be approximately 10 raised to 16 Schottky defects per 1 centimeter cube, we can say it at room temperature. Okay, thus there is one Schottky defect per 10 raised to 16 ions, and Schottky defect is shown by an ionic substance in which cation and anion are almost similar size. Means if size difference होगा, ionic compound है तो Frankel defect. if size difference थोड़ा भी नहीं है, means दोनों का size same है and vacancy defect हो रहा है, तो it will be a Schottky defect. Okay, so some of the examples are NaCl, because देखो सोडियम 11 नंबर होता है एंड क्लोराइड 17 नंबर होता है, उसका मतलब कि ये दोनों का साइज डिफरेंस बहुत नहीं होगा, उसका मतलब कि the cations and anions are similar in size, so they will be producing a Schottky effect respectively. Okay, So here, for example, NaCl, KCl, CHCl and AGBR, and we can see that AGBR is in both Frankel as well as Scotch effect. So it is an exceptional case. Otherwise, both the defect in all the compounds are not possible. Okay, so it may be noted that the AGBR shows both Frankel as well as a Scotch effect. Okay, so here we have given diagrams and you should always draw a diagram to a definite value. ठीक है, मीन्स देखो इसमें फ्रेंकल डिफेक्ट की बात करते हैं तो इसमें ये जो ग्रीन कलर का कैटायन है ना, वो क्या हुआ, तो कि इट इज पॉजिटिव चार्ज, तो कहीं पर उसका नेगेटिव चार्ज मतलब वो कहीं पर सेटल नहीं हुआ है, वो क्या हुआ, कहीं से पॉजिटिव आयन निकल कर वो वहां पर आके आए, मतलब वहां जो स्क्वायर दिख रहा है ना इन सेंटर, सो दैट पॉजिटिव आयन इज सेटल टू 1.25 फिगर इन, ये ग्रीन वाला हो गया, ठीक है। बट स्कॉच इफेक्ट में क्या हो रहा है कि दो जगह पर स्क्वायर है, तो एक जगह पर से क्या गया कैटायन, तो दूसरी जगह से एनायन गया, मतलब एक पॉजिटिव चला गया दूसरा नेगेटिव चला गया, तो पहले इलेक्ट्रिकल न्यूट्रलिटी थी, अभी क्या हो गया, इलेक्ट्रिकल न्यूट्रलिटी हो गया। तो ऑलवेज रिमेंबर, if you have asked the Frankel defect, Scotch effect, you should write about the density, you should write about the size, you should draw the figure. Okay, so if anybody has doubt in any kind of imperative defect or any kind of defect, then please ask me in a comment box. Okay. Bye.